Hello class, this is 1.8, so the second lesson when I'm not here. I'm still in Catalina right now. Um, Let me show you. Again, you can download this from Tolognet, going to topics, and there is the lesson 1.8 that you need to have and take notes about it. So the first part is actually a little review of polygons that I should have seen in, I hope, middle school. But if you haven't, I go a little bit faster, but they're all about definitions of polygons, what it is. Um, so first, a polygon is a closed figure. That's the first closed figure that has at least three or more segments, and each of these segments intersect two other segments at their endpoints. For example, if you take a look of this AE, right, and CD, they do intersect in another point here in the middle. In this point, we can call it F. That is not the endpoint, so this is not a polynomial by that part of the definition. Then the last part is not two segments with a common endpoint are collinear, because I could have a figure like this, 1, 2, 3, 4. Okay, sorry. And here I have two segments, so one, right? You see those endpoints in the middle, and these are still collinear on the same line, so there is not a polynomial. And it has to be closed. This is open because it's not a closed figure. So between these three in the first page, only this one is a polynomial. Okay, a polygon. I keep saying polynomial is polygon. Sorry, thinking about algebra 2 right now. So to name the polygon is pretty easy. You just go start from one letter. Let's say I start from D, and I go in order of the vertices. These are vertex, one vertex, two vertices, right? So that could be a name of the polynomial. I can start from the letter M. Here is this. I can start, for example, like from the letter M and go in that direction. So MKHDBG, that's a name of this polygon. The sides are all the segments, so they're listed over here, and all these are all the angles, right? And right now you don't know the measure of the angles and which one are equal to which one, and we will see that later on in the year. Okay, moving on to next. This page you can just take a look. It just names for polynomials depending from their sides. So obviously 3 is a triangle and 4 is a quadrilateral, and I'm expecting you all know the 5 is pentagon. So hexagon, heptagon, octagon, nonagon, decagon. I'm not gonna ask you the names maybe for 7, 8, but at least until 6 you should know. And the n-gon, oops, I keep moving this. N-gon, it means n side, and this is n, the number of sides, and adding gon at the end. One more definition is convex polygon and concave polygon, and the way to determine is one polygon is convex or concave. You just draw the diagonals. Diagonals are connecting two vertices. They are not consecutive. So for example here AT is a diagonal, RD is another diagonal. So if I draw all the diagonals and they're all inside, is a convex polygon. And in this case, when at least one diagonal is drawn outside of the figure, that's called concave. Another way I usually try to explain, so if you have something like this, that has kind of a, Pac-Man kind of thing. Remember Pac-Man? I don't know if you even know Pac-Man, but this part here. So it means this is definitely concave, because if I draw the diagonal here between these 2 points is outside of the figure. Even in between these 2 points is outside of the figure. An example: classify the polygon by its number of sides. So here I have 1, 2, 3, 4, 5, and 6. So is an hexagon. And tell whether the polygon is convex or concave. So if we draw diagonals for the vertices, these are inside, this is going to be inside, inside. So they're all going to be inside, so it's a convex. Okay? So it's a convex hexagon. I just do quick examples, and now you have a bunch of those. You have these examples to put on your Evernote, and like I wrote here, you don't have to draw the figure because it's right here, right? And you have the notes. So, but just answer on your notes, and you say, a figure 1 is what kind of polygon it is, and if it is a polygon, or if it's not. Okay, that's in this other example from 5 to 7 is name the polygon and identify its sides and angles. So you need to list which one are the sides and which one are the angles. And in the last set of examples, classify the polygon by its numbers of sides again, and tell if it's convex or concave, right? So just write very easily, just write the number of the example and the answers for all of these. And as I told you, I went a little fast because that was kind of a review. This is the real 1.8, talking about perimeter, circumference, and area. So the first part is about the perimeter, and since I'm supposing that I'm going to give you all this, and you have some exercise on Math Excel. Okay. So the perimeter is the sum of all the length. So for example, for the square is the sum of all 4 of these, and since it's a square, they're all equal to each other, is 4 times this value s. The rectangle is 2b plus 2h, where b is the base and h is the height, right? And for the triangle is the sum of the 3 a, b, and c of the 3 sides. For the circle, this is 2 pi r, where pi, I'm going to tell you in a second, is 3.14, right? Or you can call it pi d, because the diameter, I forgot the pen, the diameter is 2 times the radius. So this is the radius from the center to the circumference. The diameter, if this is this and this are all congruent, is 2 times the radius. Here I'm just telling you how much is pi on this one. It's 3.14, and one way to you can plug it in. If you have a calculator, it gives you exactly the exact value. If you don't have, you can use 3.14. 22 over 7 is an approximation of that number. You can use that too. The second part, it talks about areas. So area of the square. Definition of the area of a polygon is a number of square units it encloses. So in this case, I have the side S times the side S, because that's S2. So the area of the square is this area over here, that is S square. The area of the rectangle is the base times the height, and it's gonna cover this area over here, so base times height. The area of the triangle is the base and the height divided by 2. If you notice, there's a right triangle here, so the height must be 90 degrees with the base. And the area of the circle is pi r square, with r again is the radius, right? Those formulas, I think you all know it. They're nothing new. Postulate. Area addition postulate is just say the area of a region is the sum of the areas of its non-overlapping parts. And I'm going to do an example, and this section is a lot kind of, I think it's shorter than the 1.7. Let me see. So in this example, I need to find out the area of this figure. And the way you can divide this figure into non-overlapping figures. So I'm going to divide it simply like this. If you notice, this is 3, this must be 3 because it's congruent. This is 3, this is 3, again 3 and 3, right? So that means that this is also, if this is 9, 3, 6, 9, so this is 3, each one of these is 3, and this is 9, and this is 6. So simply, if this is A1, A2, and A3, or I'm just looking at the figure, so the first figure, let's get this. So the area of this one is going to be 3 times 3, that is 9. The area of the second part, 6 times 3, that is 18. And the area of the last part is 9 times 3, that is 27. So the total area of the figure, you add 9, 18, and 27, that is 54. 54 centimeters square. Remember that the area always have the unit of measurement, that is square. Now there is a problem you do this on your notes, and you attach on Evernote. And wow, this is shorter than the others, so that's it. So do the Math Excel after you're done with your notes, and I'll see you back on Monday. Okay, bye. Oops.